Okay, so this is chapter 4, assignments. Okay, all right. So first one, uh, sailboat runs before the wind with a constant speed of 4.2 meter per second in a direction 32° north of west. Okay, so here is west, right? 32 north of west. Okay, so this is west, and this is north, east, west, right? Okay, so 32 north of west. So this is the west, the 32, so this direction. Okay, 32 north of west. How far A, west, and B, north had the sailboat travel in 2.5 minutes? Okay, so what do we know here? This, so V equal to 4.2 meter per second, and this direction, right? And then time equal to 2.5 minutes. All right, so we have to turn minutes to seconds. So 2.5, 1 minute equal to 60 seconds. All right, this much seconds. And travel with constant speed. So this speed keep the same. Okay, so just always travel in this direction. All right, so I'll ask you about the in this much time. West and north. So this is a west. So what you do here is you break down this velocity into two directions, right? So velocity in west direction and the velocity in north direction. Okay, so v west equal to um, 4.2. You see, this is 32, right? Cosine 32. Okay, so you have to look at this triangle, this right triangle. Okay, so this guy and so basically this guy, right? So this guy is same as this guy. Okay, so west will be adjacent, so the cosine. Okay, that's the velocity in the west direction. So the distance in west direction travel equal to velocity in west times time. Okay, so equal to 4.2 cosine 32. This is time, so this is 150 seconds, right? So times 150. Okay, so times this together. And distance travel in the north direction, right, equal to velocity in north direction. So this is this guy, right? So this is a sine 32, and then times time times 150. Okay, right. So this is the calculation. Make sure don't confuse with the angle between the vector and the x-axis. Okay, so you use this angle because this asks you about the west and the north. You see that this is the velocity, and ask you travel in the west and the north. All right, so you just look at what this velocity is, then times time, and what this velocity is times time. Okay, so it's the distance travel in west and north. All right, second one. Starting from rest, a car accelerates at 2.0 meter per second squared. So we know A equal to 2.0 meter per second squared. Up a hill that is one inclined 5.5 degree above the horizontal. So okay, this is a hill 5.5 degree above the horizontal. How far horizontal? Okay, so this is a car. Drive this way, right? Vertical has a car travel in 12 seconds. So we know t equal to 12 seconds. Horizontal, okay, so this is acceleration. So this is A, okay? And start from rest. What do we know here? It's V not equal to 0. So this is also a two-dimensional problem, right? So this is a horizontal, this is a vertical. All right. Well, so you can do here this. We know acceleration, you have two directions, right? So you have horizontal acceleration, vertical acceleration, right? So this is vertical This is horizontal, we call it parallel, and perpendicular. All right, so we break down this motion into two dimensions. So horizontal and vertical. Okay. Okay, they call it horizontal. Let's call it vertical. All right, so for this motion, because it starts with 0, so horizontal initial velocity is 0, vertical initial velocity is 0. Okay, so horizontally, your acceleration AH equal to A, you see, cosine 5.5 degree, and vertical equal to A sine 5.5 degree, right? Okay, so in horizontal motion, initial velocity is 0, acceleration is this, right? And then give you time. So d horizontal, okay, is so look how far. It's basically displacement, right? So v naught h t plus 1 half ah t squared, right? So this guy is 0. So the first term is gone. Ah is a cosine 5.5 degree. Time is 12 square, second square, right? So a here you plug in 2.0. Okay, so that's the distance traveled in horizontal direction. Same thing for the vertical, equal to v o initial velocity t plus 1 half a vertical t squared. This is 0, so this guy's gone, and equal to half AV, right? Vertical acceleration equal to A is 2 sine 5.5 degree, and then times t squared, 12 squared. Okay, use a calculator, you can figure this out. All right, number 3. A skateboarder travels on a horizontal surface with initial velocity of, so this is v naught equal to 3.8 meter per second towards the south. Okay, so here we have to south, east, north, west. Okay, initial velocity v naught towards the south. Okay, so this is v naught. Okay, and a constant acceleration towards east. Okay, so a is 2.2 meter per second square. Okay, so this guy is 3.8 meter per second square. All right, so this acceleration toward east. Let the x direction be the eastward and the y direction be the northward. Okay, so this is y, this is x. All right, and let the skateboarder be at the origin when time equal to 0. What are her x and y position at t equal to 0.8 seconds? Okay, so now time equal to 0.80 seconds. What are her x and y velocity at 0.8 seconds? Okay, so basically ask you your position, x and y, right? And ask you vx, vy. Okay, first let's see what kind of motion it is. All right, so this is two-dimensional, and you can tell initial velocity is this direction, okay, in the y-axis. Okay, so you can break down into two-dimensional motion, right? So in x-axis, v naught x is 0 because there's no initial velocity in x-axis, right? Ax equal to 2.2 meter per second squared, so towards east, right? And then and then you have time equal to 0.80 seconds, and also you know x naught is 0. That's all you know in x-axis. So you can figure out what is x at this time, right? So x minus x naught, this is delta x, right? Or also we call it dx, equal to v naught xt, because they have motion with constant acceleration, plus 1/2 a xt squared. All right, so this is 0. So x equal to, this is 0, right? So this is 0, equal to 1/2. Ax is 2.2, and the time is 0.80 squared. Okay, so that is your x location. What is Vx? Vx equal to v naught x plus axt, right? So Vx is 0 plus ax 2.2 times 0.80. Okay, so this is a Vx, Ax. All right, so this is basically this one and this one. Now let's look at what is y. Okay, so in y-axis, you have initial velocity, so y-axis, v naught y equal to negative 3.8 meter per second, right? See, this is in the negative axis of the y, and ay is 0. There's no acceleration in y-axis, all right? Well, so this is pretty easy, right? So what delta y equal to, so this is also dy equal to y minus y naught equal to, well, you have motion with constant velocity, right? So equal to v naught y times time, right? So equal to negative 3.8 times time 0.00, okay? And this guy is 0, so you can tell y equal to negative 3.8, 0.80, right? Okay, so this is your, whatever it is, this is your y position. And the y velocity, right here, vy, right, equal to v naught y. It's always same, right? Because ay is 0, right? So this is, you see, negative 3.8 meter per second. All right, so you finish this blank and this blank, right? Velocity. All right, so next one. A diver runs horizontally off the end of a diving board with the initial, okay, so horizontally, right? Horizontally with v naught equal to 1.85 meter per second. If the diving board is 300 meter above the water, what is the diver's speed just before she entered the water? Okay, so what happened here? This is what happened, you see? Right, speed will have a horizontal and a vertical, right? Okay, all right, so here, same thing here, we break down into two-dimensional motion. And we only need to figure out the speed, right? Well, we know in x-axis, this is motion with constant x-axis, motion with constant velocity, right? So Vx equal to Vox. And because you move horizontally, Vox equal to, you see, this velocity tells you Vox equal to 1.85 meter per second, Voy is 0. Okay, you don't have any y components in initial velocity. So this equal to 1.85 meter per second. That's always same, right? What happened in y-axis? Y-axis, we know ay equal to negative g, because we always consider this is y-axis, this is x-axis, right? And initial velocity in y-axis, Voy is 0, right? And you see this problem tells you that delta y equal to, you see this is the initial position, this is the final position, it's negative 3 meter. Okay, so you see your displacement in y-axis is negative. Okay, so how to figure this out? We have to know what is your velocity in y-axis when you reach this displacement. There are a couple of equations we can use. So this equation, we will use this one. So if you have a motion with constant acceleration, then Vy squared equal to V naught y squared minus 2g delta y. Okay, so use this equation. All right. So vy squared equal to 0 squared minus 2, 9.81 negative 3. Okay. So this is you see negative here is positive, right? So basically is a 2, 9.81, 3.00. All right, so Vy equal to, then you square root of this value. Okay, but when you do square root, you have positive and negative. And in this scenario, so this guy, when you add, you get here, right? So this guy is negative. Okay, so Vy is negative. Because you are in the direction of moving down, right? All right. So now you have a Vx, you see, this is Vx. And then this is Vy. And ask you speed. Okay, speed basically is it's a magnitude of this velocity. So this is Vx, this is Vy, right? Vy down, and then you have to figure out this guy. All right. So speed is magnitude of velocity, right? So speed magnitude equal to Vx squared plus Vy squared. Okay, so this is Vx, and this is Vy, right? You squared. So basically you make a, so even this is negative, right? So you have to square it. Okay. All right, just plug into this equation. That's your speed. Okay. Make it more clear. So when you get here, right? So x, Vx, this is Vy. So you have to combine together, figure out this guy. So this is the final velocity. And look at the speed of this, magnitude of this final velocity. All right. Okay, next one. Playing shortstop. You pick up a ground ball and throw it to second base. The ball is throwing horizontally with a speed. So this is V naught, right? So V naught equal to 18 meters per second, directly towards A. Shown in the figure below, when the ball reaches the second base. Okay, so now we know time equal to 0.54 seconds. It is caught at B. Okay, so B. How far were you from the second base? Okay, so basically ask you about this. This is your ask you about dx, right? Displacement in x-axis, also called delta x. What is the distance of vertical drop, right? So basically ask you this. So this is your dy, also equal to delta y. Okay. All right. So what do we know here is initial velocity, right? Time. Okay. So we know this is same. Motion in x-axis is motion with the constant velocity. So we know dx, very simple. Dx equal to vx times time. And vx equal to v naught x equal to 18 meters per second. You see, this is initial velocity. And you only have horizontal direction, right? So this equal to v naught xt equal to 18. T is 0.54. Okay, so this is a horizontal displacement. And what is vertical displacement? Dy, right? Dy equal to v naught yt minus half gt squared. So this is equation. Y-axis, you have motion with constant acceleration. Ay equal to negative g. All right. So this one, v naught y is 0 because you see this is v naught, and v naught x equal to 18 meters per second. V naught y equal to 0. All right. So this guy is 0, negative half, 9.81, 0.54 squared. Okay, so this is dy, right? Dy is a negative value because it's down, right? But if we ask you what is the distance, ask you about the ask you about the Distance is the magnitude of displacement. So basically, you input a positive value in this blank. Okay. Distance is the magnitude of displacement. Displacement give you direction. It's down direction, but the magnitude will be your distance. All right. Number 6. A swimmer runs horizontally off a diving board with a speed of this. Same thing here, right? Diving board. Okay. All right. So this is horizontally 3.32 meter per second, and hit water horizontal distance 1.78. Okay. So this guy hit the water, right? So here. And we know dx equal to 1.78 meter. All right. From end of the board, how high? Ask you how high. How high? About water was the diving board. Okay, so this kind of problem, same thing here. What happened in x-axis? What happened in y-axis? Okay, so x-axis, you have motion with the constant velocity, right? So v o x equal to 3.32, right? You also know dx equal to 1.78 meter. Okay, so from this we can tell what's the time, right? So in air time equal to dx over vox. It's a time. Okay, so that's time, right? Y-axis, we know ay equal to negative g, right? And v naught y is 0. Okay, so we can tell delta y, right? Displacement in y-axis dy, okay, equal to v naught y t minus half gt squared. Okay, so this guy is 0, and we figure out time here, right? So plug here equal to negative 1 half 9.81 t, right? 1.3.32 squared. Okay, so this is your displacement in y-axis. And now you see h. H is a distance, right? So h, you see this dy is negative, h is negative dy. Okay, h basically is magnitude of the dy. Alright, so you can just pick whatever the magnitude here. Dy is negative, right? So you pick out you just fill in the negative, you fill up the magnitude, okay, of dy in the blank. Okay, alright, number 7. The second baseman tosses the ball to the first baseman, who catch it at the same level from which it was thrown. Okay, so same level. Alright, so like this, right? Same level. Okay, alright, so that's what happened. The throw is made with initial speed. Okay, at an angle 37.5. Okay, so this is throwing about horizontal. What is the throwing component of the ball's velocity just before it caught? Horizontal component. Okay, horizontal component is this, right? Just talk about horizontal component. Horizontal component is the same all the time, right? So Vx is horizontal component equal to Vox equal to V cosine 37.5 degrees, right? So this is motion in horizontal direction, is motion with constant velocity. Okay, so basically you have to break down this initial velocity into horizontal and vertical, right? So this Vox equal to Vo cosine 37.5, and this Voy equal to Vo sine 37.5. Okay, so what is the horizontal component of the ball's velocity just before it is caught? It's always the same. This guy. For what amount of time is the ball in the air. All right, so in air time. In air time actually depends on the initial velocity in y-axis, right? So we know, well, we know if we figure out the how long does it take to reach a peak, right? And then in air time will be double the in peak time. All right, how long does it take to we can do the in air time by using this way, using the displacement in y-axis, right? So we know delta y is 0. So start from here and here, right? So in y direction, displacement is 0. Okay. Also, we know delta y equal to v naught yt, okay, minus half gt squared, right? So from this equation, we can figure out in real time, right? So 0, right? So this is 0 equal to v o y equal to v naught sine 37.5, and then t minus half gt squared. Okay, so we divided by t on both ends, right? So this gave you, so t cancel only 1. So we can figure out t equal to 2 v naught sine 37.5 degree divided by g. So this is your in air time. Okay, so this also equal to 2t peak. Okay, so t peak time, t peak equal to v naught sine 37.5 degree divided by g. Okay, so that's the answer in air time. Just plug in everything in. Number 8. A golfer gives the ball a maximum initial speed of this. Okay, so this is a maximum initial speed, so v naught. Alright, what is the longest possible hole in one for the golfer? Alright, neglect any distance, the ball might roll on the green and assume that the tee and the green are at the same level. Same thing here, right? So, same level. Okay, ask you about the longest dx. Alright, so we know longest dx happens at theta equal to 45 degree. Okay, so we know dx longest equal to, alright, so v naught cosine 45, right? So this is initial velocity in x-axis times in air time. You see, in air time, same thing here, right? So 2v naught sine 45 divided by g. That's it. Okay, just plug in. You see, this guy is 51.4. Okay, so 2, right? So the 51.4, 9.81. Okay, so this is equation to plug in. This also equal to v naught square. You see, 2 longest one divided by g. Okay, because cosine 45, 2 sine 45, this equal to sine 90. Basically, it's a sine. So the trig identity we use here is 2 cosine 45 sine 45 equal to sine 2 times 45. Okay, so equal to sine 90. Sine 90 is 1. Okay, so this is 1. So this is v naught squared divided by g. Alright, B. What is the highest tree the ball could clear on its way to the longest possible hole in one? This is highest tree it can clear, right? So basically ask you about the height. Well, how to figure the height? Okay, so here is the equation. Right. So this is your, basically this is a range, right? Okay, and well, we know height, right? So height equal to dy, right? Start from here, you reach here, right? This equal to v naught y t minus 1 half gt squared, okay? V naught y equal to v naught sine 45, right? What's the t? Well, we actually, from here, that's the time to reach a peak, okay? So this is v naught sine 45 divided by g. That's a t, time to reach peak, minus half gt. T is v naught sine 45 divided by g squared. And in class, we'll also show you what is this, right? What is the height, right? So height equal to, if you look at this guy and this guy, right? So height will be v naught squared sine 45 squared degree square, right? So this is g, and you have 1 over 2g, right? So basically, you can not with 2g here. Okay, so this is the equation for the height, how high it can go. When we talk about in general range, general angle, general launcher angle, you have r, okay, r is called range. Then you have a peak, how high you can go. All right, so just two equations, which is the use of two equations. All right, number 9. In a friendly game of handball, you hit the ball essentially at ground level and send it towards the wall with speed, okay, and angle. All right, so here, this problem, we know speed, 16 meters per second, and angle above the horizontal. Okay, so this is the initial condition. And what amount of time is required for the ball to reach the wall? 3.3. This is the wall. Dx, okay? Dx equal to 3.3 meters away. So what happened here? You see this guy, right? Hit the wall. That's it. And also ask you about what amount of time it requires, and then how high is the ball when it hit the wall. Okay, so ask you about this one. Ask you about dy, right? Okay, so we have to break down this into velocity. So Vox equal to 16 cosine 37. Voy equal to 16 sine 37. All right. And then we know dx is 3.3, right? So in x-axis, we know time. Time equal to dx over Vox, right? So equal to 3.3, 16 cosine 37. Okay, that's the time. That's in air time. That's the time you hit the wall. And then ask you dy. dy equal to v naught yt minus half gt squared, right? So v naught y is this guy. 16 sine 37 t. This is your t. 3.3, 16 cosine 37. That's the time, right? Minus half 9.81 times square 3.3 16 cosine 37 square. Okay, so just calculate this guy. Okay, so that is your how high is the ball. Okay, how high is the ball you hit the wall. Okay, so it's number 9. Number 10. On a hot summer day, a young girl swings on a rope above the local swimming pool, shown in the figure below. When she lets go of the rope, her initial velocity, okay, so this guy is 2.25 meters per second at an angle 35 degrees above the water. If she is in light. Okay, so T air equal to 0.66 seconds. How high about water was she when she let go of the rope? All right, so here is the water, right? So from here to here. Okay, so this is in air time, right? So what do we know here is initial velocity, angle, and ask you about this. This is your dy, right? So this is air time. In y-axis, this is your dy, right? So how high above the water? So basically, you look at dy. dy equal to v naught yt minus half gt squared, right? So this is v naught y. You see, this is v naught sine 35.0 degree, right? So times t is 0.616 minus half 9.81, 0.6. Okay, and you can tell this guy is negative value. It's plug in, right? So this is a 2.25, right? And then plug in, you can get a negative value because indeed in displacement y-axis is negative. So h, how high, right? You look at the distance from the water. You look at this distance equal to negative dy because dy is negative, and then this is whatever, just like you got a negative value, right? So negative something. You distance is the magnitude of the displacement. You look at you just pick the magnitude here. Dy is a vector. Negative means you move in the down direction, and the magnitude is the height. Okay, mathematically equal to negative dy, which is a positive value. Okay, all right. Number 11. A player passes a basketball to another player who catch it at the same level from which it was thrown. Okay, the initial speed of the ball is so like this, right? 7.1 meter per second, and it travels a distance 4.6 meters. So dx equal to this. A, what was the initial direction of the ball? And B is time of flight. So basically what you know here is this. You see, you don't know angle, and you know V naught equal to 7.1 meter per second, and you know dx, right? dx equal to 4.6 meter. Okay, well, ask you in air time and angle. Okay, so we can use, basically we use the equation. So displacement, this is range, right? So we know range equal to, okay, so the range equal to, so this is 4.6 meter, right? So equal to V naught cosine theta, right? Times T in air, right? So this range. And what is in air time? T in air, right? So from, we know range, we know T, we're looking for T in air, right? So we know V naught, okay? And also we know T in air equal to V naught sine theta, right? Then you have, in air is, okay, let me see the equation in air time. Let me see. So this is in air time, right? Two peak time, 2 times of this. You see, this is in air time. Okay, so this is 2 V naught sine theta divided by G. Divided by G. Okay, so let's see, what do we have here? We have V naught in here, so we can plug in, right? So we plug in. So R equal to V naught cosine theta in airtime 2 V naught sine theta divided by G, right? So this equal to V naught sine 2 theta divided by G, okay? So in this equation, we know two things. We know what is R. R is 4.6 equal to V naught 7.1 sine 2 theta. Wait, let me see. R in air time. No, actually 2 square, right? So this is squared. Okay, so squared. You see, this is V naught, right? Cosine sine 2, so sine 2 theta divided by G, so it's square, right? So this is 7.1 square divided by 9.81. Okay, so from this equation, we can figure out what is your sine 2 theta, right? So you see sine 2 theta equal to 4.6, 9.81 divided by 7.1 square. And then you do 2 theta equal to inverse sine. Okay, so that's the whole thing. Then theta equal to whatever you get from the calculator divided by 2. Okay, so this is angle. This is initial direction and time of flight. Once you know the initial theta, right? So plug into this equation to figure out time of flight. Okay, time of basically in the air, right? So you know this is 7.1. So basically T air equal to 2, 7.1, and then sine whatever here you get divided by G. Okay, so that's the number 11. All right. Number 12. A golfer is a strike with a 5 iron on level ground. It's landing, okay, 92.2 meters. So basically range, okay. Away, this is 4.3. So you know in air time. Okay. What are A, the direction, B, the magnitude of the initial velocity. So ask you what is V naught and theta. Okay. So we can just plug in, we can use the equation directly, right? So R equal to V naught square sine 2 theta divided by G, okay? And T in air time equal to, let me see this equation, right? So 2 V naught sine theta divided by G, that's in air time. And range also equal to V naught, let me see, V naught, okay, sine theta 2 cosine theta squared divided by G, right? Okay, so we know range. Okay, so we know range. And then also we know this guy in air time, right? So what we can do here is, okay, so what we know here is, so that's what we know, right? So you can tell you have two equation, right? So two equation, and you have two unknown. Unknown here is V naught and angle, right? So from first equation, we just plug in, right? So this is in air time, so let's plug in, right? So plug in here is 92.2 equal to 2 V naught square sine theta cosine theta. We can put G on this end, right? So this guy times 9 times this equal to that one, right? And the air time is 4.30 times 9.81 equal, you see this one, equal to 2 V naught sine theta. Okay, all right, so we know from this equation, this is the second way, so V naught sine theta equal to 4.30, 9.81 divided by 2, right? And then we can plug 2 sine theta here, right? 2 V naught sine theta. We substitute, okay? So you see 2 V naught sine theta, then V naught cosine theta, right? Okay. You see, we can plug here, substitute V2 V naught sine. So the whole thing we can write out as 2 V naught sine theta, V naught cosine, right? So we can tell V naught cosine theta equal to 9.81, 92.2 divided by that one, right? Divided by this guy, 4.30, 9.81. You see that? All right, so just we just like move around. We get this two equation. So this is 1, this is 2. So what do you do next? One is 1 over 2. Okay, so 1 over 2. You see, divided, right? So cancel. Then tangent theta equal to this whole thing divided by this whole thing, right? And then whatever you get, right? Then theta equal to inverse tangent of this thing. Okay, so you get an angle. Once you get an angle, then you can plug into whatever equation, right? You can plug into this equation. Okay, so you know in air time, you know angle, you know G, 2 is given, right? You can figure out V naught. All right, so bottom line, give you two equations, right? So there's two equations, and you have two unknown. Two equations, two unknown. You can solve for two unknowns. All right, so that is number 12. Let's look at the next one. A soccer ball is kicked with a initial speed of this. After 0.75, so t equal to 0.750, it is at its highest point. What is its direction of motion? Ask you about this, right? So this time actually is your peak time, right? We know peak time, right, equal to V naught sine theta divided by G. Okay, so that's peak time, the time to reach peak. Okay, so you know peak time, and you know V naught, and well, looking for angle, right? So that's all you need to looking for. So angle is, well, just plug in, right? 0.750 equal to initial velocity, 85 sine theta divided by 9.81. Okay, and you can find the sine theta, right? And then theta equal to inverse sine of this guy. Okay, so that's what you got. All right.